Thank you very much. Flow maps are very rare, right, as compared to most other thematic maps. I can spot a couple of issues. One is they're very difficult to create. You either need to code to generate a flow map just like the one that you see. That is not a simple line between an origin and destination. The curvature is customized with a half arrow. Anyways, and also, it's very difficult to find data to map flows. If you have ever tried that, try giving your students an assignment about mapping flows. Then you'll realize they're gonna map the same flows over and over and over and over and over again and again. Okay, so that's my startup. So now we're going to switch forward to the tool, the FlowMapper. That's something I had to try before I showed anything to you. Of course, things break. So we built this tool a couple years ago with my master's student. One more student worked on it, but it's work that, you know, took nearly a decade to make this available on the web. And it actually existed before, but Flash died. It was developed in ActionScript. So the next thing is JavaScript to die. Okay. So how do you make flows? So in the flowmapper.org application that we built, so you need a node file, which needs to have a unique ID for each node, and X and Y coordinates. These are lat-long coordinates. So I'm just not gonna deal with searching stuff, so I can save time. So you'll need to, I'll show you some tricks how you can find such data. But once you load such data, it's a CSV file. You're going to select the ID, that's the ID, X and the Y coordinates. Whether that CSV file has anything about the nodes. The nodes could be actually conceptual point locations, or it could be the centroids of the conceptual point location. Well, sometimes the points are not conceptual, it could be actual points of where the flows could be. So in this case, these are actually from the provinces in Mexico, and I'm gonna pick total flow. And regions, you can actually show a choropleth map behind the nodes and the flows, but I'll get back to that. So I'm just gonna pick, currently I don't, that's another issue. We constantly update this application because, for instance, we don't have enough map projections, so I'm just gonna have to use the terrible Mercator. And let's upload the flows. So these are the flows. If you actually Google internal migration world and pop in there, for whatever reason that keyword finds you the data. So then you'll find all the internal migration flows in Africa, in Asia, in South America. So this is from that set. So I'm just gonna simply upload that file. You're gonna have to say this is the origin ID. The flow file has 3 columns, very simple. It needs to have an origin ID that matches the node ID that you uploaded. Destination ID, so that should be existing in the node table, and a volume, you know, how much flow of whatever, how many people moving in between, for instance. Okay, so this is done. Lots of other controls are pretty much visual variables. So I can say that let's display the nodes with a kind of in, I don't know, blues. You can symbolize them with the flows. Yeah, let's try first. all black. It doesn't matter. Okay, we map. So okay, it's a mess, right? The flow maps usually look like this when in your first shot. So you can also, like I said, upload the regions, which you can turn your shapefile for the choropleth map into a GeoJSON and upload as a background. And you can, if you have any attributes, you can upload that attributes and join them. So this is how you match the join through the common ID. And let's say population density. Here I want to show population density. I want to use, let's say, oranges. So here I have a map of the population density in Mexico. You can build to the extent. You see the flow legend is here. So one thing about flow maps, and another issue. So when it comes to choropleth maps, we know we don't map row counts. But when it comes to flow maps, I even sometimes don't care that I map the row flows. But there's a problem, because larger the units, more flows there could be between them. So there should be a normalization. So there should be a baseline that you should compare your flows to. Because I broke that tool that is actually available, normalize flows, you click here, and it gives you the formula. You can use a gravity model. We'll add all of these here, but because I was experimenting with lots of things yesterday and today, I somehow broke it. But I'll show you one thing. I'll show you, I was able to actually get this process earlier. Modularity flows, which we apply one of those statistical techniques to normalize the flows so that we account for what is above expectation between an origin and a destination. So if I do that, now you realize all of a sudden the flows, these are the flows that are expected. Of course, if you see, I don't want to see the top 100, I want 300. Okay, here you go. Oh, that's fill opacity. It shouldn't allow you to enter 300 in there. That's another bug. That's another bug. It's just, okay. So here I have this, and I can do a lot of different things. So classification, we can apply classification, both the color of flows and also the width of the flows. So I can use quantiles, for instance. I can say, let me do 3, 4 classes, let's say. 4 is fine. And I can use like a color scheme, color brewer choices here always. Let's pick green. Map the flows. So now you're starting to get a bit more interesting. Maybe if you increase this a little bit, and you can decrease the flow lines or increase the minimum and maximum width. So the stroke color is sometimes very important because, you know, I can pick a different base map too. So I can use a dark base map, which things tend to get fancier when it's dark. I didn't mean that, but yeah. But anyways, you can click on nodes to visualize flows to and from the nodes. And you can do lots of different things. Like I said, visual variables. I can play around. We have lots of different flow types, and we're going to keep adding on to this. So here's straight flows, if you like straight flows. So if you want like teardrop, this is from Colin Ware. Apparently this helps the visual cognition. Let me see. There's also one other addition that is quite experimental and not working yet, but I'll show you a quick snapshot of that. I've implemented this in ActionScript, I promise, but now, so the flows, the origins are red, destinations are blue. You can also apply line shortening through applying transparency in between. So then in between the flows, they disappear. Of course, you also have to get this done. Well, of course, the background here doesn't work very well. I shouldn't have tried that, but I guess that's pretty much it. And this is not really the end product. I can make this as nice as this one that you see here. I'm not sure what that message says, but grant access, okay. I don't know. Lots of weird stuff is happening. Now it's all gone. I still have 5 minutes. I expect this is gonna come back, right? Okay. So I'll show you a few things and perhaps take a question or two. Why is it asking me to grant access? What do? I don't know. Okay, I guess it's not going to cooperate. Okay, it works. So in fact, cartographic principles will not be enough to make good flow maps. We need to have, well, actually, if you include map generalization as part of cartographic principle, yes, they are enough. But it involves like a generalization approach that is much more difficult than what we know. It influences like the flow density. It needs to look at flow density and also selection. So we actually have a previous paper that allows us to do multi-scale flow maps, and you see it pretty much generalizes all these like flows into the significant flows, so that you just only show the significant flows while you hide the rest of the flows. So this will also be integrated into FlowMapper in the near future, as near as possible, but I don't know when. So this is the example from that Flash-based FlowMapper application that died. So that has the line shortening, as you see. The flows kind of in the point of line shortening is that it kind of reduces visual clutter in between, where you expect to have more flow lines. Well, that's about it. So if you have any students who are interested in working on flow maps and in geovisual analytics in general, I'm looking forward to having them. Any questions?
All right, we have time for one question.
Is that data, the data it creates with the flow, as well as the vector symbology downloadable, and you can pull it into spatial stuff?
Yeah.
As QGIS?
Well, the symbology, you can't do it. I don't know. I mean, you could. It's all open source. I opened it up for everyone.
Okay.
There's a Journal of Maps article. You can implement that using that, but the whole application is very complicated. That is not easy to make it work in other platforms. But one thing we are doing now is just putting up a repository, which is, if you look at the help, we are putting up all the data we find about flows all over the world into a repository we are hosting. So you can find flow data.
Let's give it up for Caglar.
Thank you.